Our next speaker is Jörg Brühe, and the topic of his talk is the database backup has finished. What's next?
Yeah. The program committee has decided or has hoped that my talk will be provocative enough to get you all out of lunch mode back into discussion mode, and I'll try to do my very best. My name is Jörg Brühe. I'm working with FromDual. FromDual is a small Swiss company concentrating on services around MySQL. So we are doing consulting, we do training, we deliver support, and we deliver remote DBA services to those who want them, and some other minor stuff depending on what the customer needs. But that's our basic or our typical portfolio of services. We are members in the relevant organizations, including the DOAG, the German user group of Oracle users, Oracle and MySQL. You can download the slides later from our company site. I will upload them there, and they will be available via the OSBC sites also. And on our slides, you can also find other talks we deliver, like the talks we deliver at the DOAG conference. For those of you who are interested, I've got some of the leaflets for this year's DOAG conference in Nuremberg here. Now more about me. I'm working in the database world, or relational databases on Unix world, basically since I finished university. And I'm doing that typically on the provider side. So I was member of a team developing a distributed database management system, and was part of the MySQL build team for several years, and then switched to the client side as a DBA, and now I'm back on the provider side in that I deliver assistance and do training and stuff like this. Deviating from the typical talks about database backup, I'm not going to tell you how you should do it. I'm not going to offer you the perfect solution, because I simply assume you have got that already. Perfect always to be seen in the context of your requirements, of your possibilities, of your budget, of your data volume, and whatever belongs there. Rather, I'm going to tell you what you should do with your database backup, and what too many people are forgetting much too often, and then they may run into trouble. So what I'm going to tell you is not specific to any database system. MySQL will be used as an example. It's not limited to MySQL. And it's not limited to any specific backup solution. Whether you do your homegrown stuff or Barreos or whatever have you, it doesn't matter, because several of the tasks apply to any environment, to any combination. So we are going to talk about the purpose of database backups. We are going to, we will talk about verification of a backup. We will discuss what to do with production data and all that kind of stuff. Why we do a backup? Well, Gracien has already mentioned it in his talk, so I'm going to skip over several of these slides pretty fast. We all know that data are essential either for a company or for a personal user. If you were to lose your holiday pictures or the pictures of your wedding anniversary or whatever, it might be close to a personal catastrophe just for emotional value. I'm not talking about money only, I'm also talking about emotions. And the emotional value of your personal data may be much higher than the financial value of them. For a company, of course, everybody talks about finance and money. So for a company, it is the risk that if you lose your company data, it may totally break your operation and may mean the ruin of your company. And there is the old saying, it sounds cynical, I know, but if data did not get backed up, obviously they are not important. The old DBA rule. If your boss doesn't give you the money to do a decent database backup, say, the disk or tape storage or whatever you prefer for it, then obviously it's not important. That's the only way to look at it and still to keep your sane mind. One thing I forgot in the introduction. If there are any questions about facts and understanding and so, please put them immediately. It doesn't make any sense that I continue talking and one or more of you have lost track and want to clarify something first. The causes or the possible causes for data loss are many. Gratien has already mentioned them. I'd like to draw your attention to the third point. Mishandling by accident or by intention is something which is much too often neglected. And even the most elaborate hardware and fault-tolerant software, etc., and replication and multiple storage and RAID system and what have you, will not protect you against the silly programmer or the malicious user who simply drops a table. Yeah, table drop will get replicated, great. No RAID system will protect you against that. That's also one of the reasons why a RAID system is no substitute for backup. The same holds on the operating system level. And so you will do your own risk analysis, and that's basically what Gratien talked about. So let's simply skip that. And as a result, you will end up with a backup strategy that fits your technical possibilities, your environment, your data volume, and the risks you considered. Customer of ours is running 2 data centers and is replicating data to the second data center. So they thought they are protected. On second thought, they noticed that both data centers are pretty close to the same small river, so flooding might affect both. And both data centers are in the same direction, close to the French nuclear power plant Fessenheim. Geographic replication is not sufficient depending on the circumstances, or may be insufficient. Now, we assume that we do have a database backup implemented. It's running regularly, it's all fine. My claim is that doesn't finish the job. You may not yet turn to other items. You've still got work to do in the context of your database backup. The purpose we already mentioned is to prevent you against data loss, but the backup by itself is not sufficient to have the purpose fulfilled. You must be sure that the database backup is fit for recovery. If it's not fit, for whatever reason, you haven't finished. So you have an acceptance criterion in the meaning of quality assurance for your backup. And that criterion is sufficient for a recovery. And your honest belief is not enough to prove that quality. You have to verify it. You have to test it. I have taken that quote from another talk. Every database backup is a Schrödinger's backup. Its status is unknown until you have used it for recovery. And only then you know whether it's good or bad. So there are obviously not only risks for your data while you're operating them, there are also risks for recovery, like a mismatch, different versions, a new version of your backup tool needing other parameters, and now the result is suddenly not suitable for recovery, or a new version of your recovery tool not accepting that old data format, or whatever have you. And of course, whatever vendors claim, there is a non-zero risk of data becoming corrupt at storage, for example, or during transfer. I once was running a small machine which was using a riser card because the case was not high enough for other controller cards, and so The SCSI card inserted into the riser card reproducibly had data corruption because some of the contacts were bad or the runtimes were different or whatever have you. So whatever I would save through that SCSI card in the riser card was damaged, regardless of the device I was using. That's a real risk, and no software will detect that, typically, until you try to recover. Your recovery procedure might be faulty or not matching your backup, and your system might be unusable for recovery, unsuitable, whatever have you. So what you need is a verification whether your database backup was okay. That means you can't simply check it by itself. You have to pass it through your recovery procedure and really recover a database instance from that backup. That's the only way to really be sure it's okay. There is no other way. There is no other check. And this check must be a routine action. It's not sufficient to do it once. When you come up with your backup procedure, it's necessary that you make that part of your routine work, or rather your automated work, running without your manual intervention at sufficiently frequent, regular intervals. And depending on the level of your paranoia, you may have any amount of checks. Just check that the database comes up with a backup, check that it contains the same number of tables as your productive data, check that the number of rows per table is okay, check for consistency, what have you. There is no upper limit. Maybe your boss will put you a limit and say that's enough, but that's a different aspect. So you want to verify that, because you want to sleep with a safe mind and undisturbed. So you have to verify your backup, and you have to do it somewhere where the restored data is protected by the same safeguards as your real life data. You don't want your customer data to appear in the open world, or your financial data. Which means you need in your production environment, with the same firewall protection, etc., access controls, etc., you need a second machine, physical or virtual, on which to restore your backup. You need a second instance. Everything else is insufficient. Yes, I know, if your database costs you a license, the recovery machine may cost you a license too. So sorry for you, but there's no way out of it. You don't want to do your restore on your productive machine. Would be really silly. So basically, you end up with at least such a setup. You have a production instance, you take a backup, and you restore it onto a recovery instance. And that recovery instance is within your production network, protected by the firewall, etc., etc. And everything else is cheaper in both meanings of the word. It's not only less money, but it's also less secure, less protective for your ease of mind, and more risky for your company. Now, we assume you have got a recovery procedure established and working. And we assume you have got it automated so that it doesn't take your valuable time and you can do better things in your day work once you have set that up. And now you have done your recovery last night of some productive data. What's your status now? You've got a production database with live data, constantly changed as orders come in and bookings are entered into the database and store supply is updated and whatever have you. And you've also got your recovery database, which has got the live data of your last backup time, say of last night, midnight. And It contains the same data, some period back in time, yes. And it's also available on a machine in your production environment, protected, etc. Great. Now, the additional difference is that your recovery machine typically is idle. The data are not changing, and there's no user working on it. Especially, there is no user who hopes for a fast response time as usable or as to be expected on a fast machine. So, this copy of live data is, of course, subjected to privacy laws, sure. But it's also suitable for various purposes. You can run statistic on them. So last night's backup might be good for running statistics of the previous week or the previous month. Statistics which you typically run on your production machine, but why should you? Especially if it's a complicated statistic, a new report nobody has expected before, a report which is not supported by indexes. So the report is really putting high load on the machine, reading all data, doing table scans, which you normally would avoid, etc., etc. Who cares on the recovery machine? Nobody. It doesn't block anybody. It doesn't block normal work. You can say, check on that recovery instance how long a create index would take. Whether you can afford that in daily operations or whether you need a nightly maintenance window for a schema change. All this kind of operation can be done on your recovery machine without disturbing anybody. So accounting, statistics I mentioned. Another item which is often a case of concern. If you do a physical backup of your database, you might have suffered from bit rot on the disk. I know it's unlikely, but every now and then you hear the horror stories. Now, who cares? You do a physical backup, do a physical restore, have a running database, and now you do a full logical dump. Who cares that it takes 2 hours, that it's putting up logs, that it would block ongoing transactions? Nobody. But that would be suitable to detect bit rot, for example. There are many purposes for which you can use a recovery machine because it contains the live data in your protected environment. You can run exports if you need that. Say your marketing guys want to do their work via Excel or some other table calculation spreadsheet. Do a comma-separated value export or ODBC or what have you, doesn't matter. Do it on the recovery machine. Basically, you can transfer any job from the production machine to the recovery machine, which is a read-only job and which doesn't need last minute's data, but say that the data of the last backup are fine. Any such job can be taken off your production machine and put you on the recovery machine, which immediately makes it easier for you to get a decent recovery machine because it's not sitting idle. You are using it for a meaningful purpose and you're taking load off your production machine, so your production users will be happy because of less load and faster response times. Typically, that's a pretty fine argument for the people controlling the budget. Now, I have mentioned data privacy, and we should not ignore that. After all, at least the majority of the participants here, I think, is running their business in Germany, so they are subject to German data privacy laws, which are a bit more strict than somewhere else in the world. So that means everything which is relating to persons is protected by law, and the amount of data you collect is limited. You must not collect data which you don't need, etc., etc. I'm not going to give you legal advice. I'm just repeating the buzzwords so that you also get them back into your mind. And typically you do have a data privacy officer in your company, at least you should have if your company is not really very small. And that's the person to consult with for all the items which will be following. And if you are really in doubt, better safe than sorry, better get legal advice on which you can rely than just follow your own instincts. My personal claim is that most IT people are logical people, and the correlation between law and logic is extremely low in my eyes. So you have to protect the personal data depending on what you do with your recovery database. Well, the recovery data are in an SQL instance. The full power of SQL is at your hands. So there's nothing that would prevent you to set the names to John Doe to protect any real life data, any real persons. There's nothing that would prevent you to change the mail address into something which is legally from the correct from the syntax, but cannot or will not support any clues about the real address. SQL gives you all those possibilities. Yes, I know the MD5 sum may be long, and I hope your field is sufficiently long, but that's a different issue. That can be solved. And as a proactive database administrator, you can live on pessimistic assumptions. It makes your life, well, it protects you a bit. One of those assumptions is that you might be the only one remembering data privacy. Just act on that law or on that rule. It will help you sooner or later. Foreign colleagues. No, that's not meant as some political statement or some feeling against them. Foreign colleagues means people from other countries may not be used to the data privacy laws ruling your company. So they may, especially when they work as developers because they are cheaper, say developers in a location abroad, they may have hopes and they may want to access data which you are not allowed to give them for legal reasons. So especially with foreign colleagues, my recommendation is really check privacy laws and discuss them with the foreign colleagues and point them at the restrictions which are governing your work. It may really make the difference because they will be really surprised. They probably know their IT work. They know what to do technically, but they may forget the legal aspect. And when people ask you for some data from the recovery database, check the schema they want to access. And if you really don't know what it means, just ask them. Better safe than sorry, as I said before. And remember all the various papers you signed when starting your work as a database administrator or as a developer or system administrator. You probably signed some confidentiality rules, and you better remember them. What I hope you will not need, but what I mentioned for completeness is the long-term company interest is much more important than the short-term desire of any colleague who says, I need those data for my work. We may think of some diesel engines. We may think of any other scandals about mishandling of data. better take care that you consider the long-term interest and not the short-term joy of your colleague. And, well, in the worst case, maybe you have to be disobedient. I hope for everybody of you that it doesn't affect you, that it won't affect you, but who knows? So why did I mention all these items? Well, I mentioned them because what you typically may get as a DBA or system administrator is a request from development. We need those data. We need those live data for our development purposes, for our development needs. Development typically is not behind the firewall because they have easier access to the outside, or should have. Development typically may not have signed the same confidentiality papers which you as administrators may have signed. So, in theory, development is a less safe area than production is. Nothing to be said against developers, but you have to consider that. What they typically want to do is they want to analyze how their features are used. Are people really entering those values? Do they make use of the newest feature added? How high is the percentage? What's the distribution, etc., etc. It's a typical developer desire. They may want to use live data to have the real volume and to have a real-world value distribution. That's also quite typical. They may want to see the data volume so that they can run explain and can check whether it pays to add an index or not. Or they want to check which actions are possible, which actions will take how long, etc., etc. Schema changes. Now, in all those cases, you have the legal aspects of the law. You have the aspects of the data privacy statement which your company issued to users. And you have, of course, the obligation you yourself signed. That's 3 different items, and all of them will matter in this moment. You better check them. And when you have done that, you will need to find a solution. How can you satisfy the developer desires while not violating your legal obligations? So for instance, in the recovery instance, after recovery has been checked and recovery was okay, you can delete critical data if they are confidential. As long as developers don't need those tables or those fields, just delete them, update them to blank or whatever, so that they will not get exported. You can replace them by John Doe or whatever, Erika Mustermann in German, no problem. As long as the distribution of values does not matter, having all values the same will not cause trouble. And you can, of course, do a selective export. Export only those data which developers may get, which may leave the protected area, while not exporting the others. You can, if it's really critical data and the data must not be, or the data must be kept with their original values to be useful, you would have to deny the export. Now, denying the export sounds like the developers won't be able to do what they need. Yes, they will. Why can't the developers provide a script which you then run in the production environment and just supply the results, say statistics about value distribution or so. So you would run the script on live data, but not let the live data leave the protected area. Developers should be able to provide a script, and you definitely will be able to run it. If not, there's something else really wrong in your environment. So basically, the result is like this. You have a production instance. You take a backup. You restore it on your recovery instance. You run scripts to delete or update critical data so that the result is not really critical anymore. And the result you can then export outside the production firewall so that developers can import it onto their machines and do whatever they need to test. No real problem, just a bit of implementation effort. Yes? Now, everything which I already mentioned is something you don't want to do manually. You want to automate it. You don't want to run the same export, the same anonymization, etc., etc. And that automation should be governed by some principles. I will give you examples now which are written for MySQL. Well, you will have to change them to your company's rules and to your company's database system, of course. And when you read the examples, the connect variable contains all the connection parameters, user, password, host, and DB is the database on which they are operating, or in Oracle speak, the schema. The principles are that you don't want to execute routine tasks manually. That's fairly obvious. Everybody wants to automate, to not repeat the same dull stuff day by day. You want the script itself to contain the success checks, and you will just every now and then do a manual check to be sure your logic is still correct and the script check is correct. But that's a rare event. You want to be alerted about errors by mail typically, not by SMS reaching you in the night, because whatever may be the problem with your export script, it's not worth you getting up at midnight. And of course, you want the scripts to adapt themselves automatically to changed environments. You don't want to maintain your script and add a new database once a new database is added to your installation or new table. You want the script to check for that automated, and if it's a new table, well, don't do anything to it. For example, don't export it if it's not yet checked. So you want the script to err to the safe side by its own built-in checks. Which parts will you need? Well, obviously, you need a backup script. That's a given and mentioned here only for completeness. You probably want some automation to clean up old obsolete logs to get them off your disk. Purge log in MySQL speak, whatever your database system calls it. You need a script to do a restore of a given backup. That's what you need for a recovery test, and that's also what you need in case you have to restore it on the real machine if the production data got defect, broken, crashed, whatever. In case you are running multiple databases, or multiple database instances, sorry, you probably want to do something for automated selection. I have always mentioned you need one recovery machine. Now, if you are running multiple database instances, probably you will have several production instances, but only one recovery instance, assuming that not two production machines fail on the same day. Yes, That's the typical assumptions. You don't expect double errors. I know flooding or fire in the data center will affect all of them, but for that you would need a spare data center somewhere else. That's beyond of what I cover here. You can have that, of course, but that's not what I expect the typical installation to have. You will need a script to check which schemas are in your current restore. That will come very handy later. You will need to handle user and password for that schema in an automated way, and you will need scripts to make the data anonymous. Now look at the examples. About the backup script, I don't give code because it's too specific to your setup, to your environment, to your database. I just mentioned what it should do. Definitely generate names which contain a date and timestamp part, because you want to know how old your backup is if you recover it. You will delete old, obsolete backups if they are kept on disk. Well, if they are kept on tape, your tape retention policy will take care of that. You will have it started by cron. What I would not put into the backup script is monitoring for disk space, because you need monitoring anyways. And I would not handle the recovery machine and the backup space and so on different from other disk space. I would have that all be handled by the same uniform mechanism throughout your installation. It will be helpful if your backup script takes care to write the backup history into the database. That comes very handy, that you can check. That you can check when your database was backed up last and what the result was. So, for example, MySQL Enterprise Backup does write such a script from the tool. If it does not, well, of course, your script can just do an insert into such a table. An effect which we stumbled upon in that case I'm building the slides on is that it's a question whether you will replicate the backup history to a slave or not. On the one hand, you backed up the master, not the slave, typically. So you don't, the slave was not backed up, so having the backup history there would be wrong. On the other hand, the slave doesn't contain any other data than you already backed up. So from that point of view, backup history also applies to the slave. In our case, it was really necessary to have the backup history because we built our purge log on it. So we were running a master-master replication, taking the backup on only one side, but purging the log on both sides, of course. And so we needed the backup history on the other side. Why did we need it? Well, as I said, purge log, we would take the backup history, select the start time of the successful backup of the last but one, time descending, limit 1, offset 1. So we would get the backup time, or the time of the last but one successful backup, would write that into a variable called timestamp, and then generate a purge master logs statement before $timestamp. For that, of course, we needed the timestamp on both sides and the backup history on both sides. Again, do it the way you like it, do it the way you prefer, add what's missing, what your tool doesn't provide. And you can get that automated. So there's no need to do any manual purge logs because the script will do that. If you don't have a history, well, assuming you do a backup every night, then a log which is older than 26 hours should be obsolete. Depends on your policies. Restore. To a restore script, you would pass the backup name as a parameter, typically. You need that in case you want to inquire into one specific database state. So you need the possibility to do a selective restore. Definitely, if you do a restore and are not on the dedicated restore server, you want to have interactive confirmation. You want to prevent yourself against an accidental restore on a production machine. That's the background. I would never let the restore script run automated on a non-dedicated restore machine. The risk of ruining my data is much too high. It will delete all existing database contents, and it will load the backup and start the database instance. That's pretty obvious. I talked about the restore wrapper. You need that to check that all database instances have their backups recovery tested as a routine measure again and again. Not only once when you install them, but as a routine step forever onwards. So the restore wrapper would only run on the dedicated restore host. You probably can give it a host name, and if you give that, it will check the last backup of that host and restore that. But if you do not give it a host name, the wrapper will check all instances in a round-robin schedule. Today, number 1, tomorrow, number 2, the day after, number 3, etc., until you have checked them all and then start with the first one again. And once it has determined which instance to check, it will call the restore script with that backup host name. Round robin, I said. Well, that's pretty trivial. After all, we are doing Linux, probably, or some other Unix platform. So we have a decent shell. Nowadays, the bash can handle arrays. So you would list all directory names of your backup, and by grep filter out those which are not database backups. Some others say it's a file system of its own. You would filter out lost and found. So you have the host list as an array. You would determine its number of hosts. You would ask your date program for the day of the year, running from 1 to 365 or 366, depending on the year. And then you would run a normal modular operation. Day, modular number of hosts, and that will round robin iterate throughout all your backups. And every day you will take the backup of the next machine until you have reached the end of the list and will then start from the beginning again. That's shell. That's simple. I said you will check which schema you are handling. So you would check the number of the list of your schemas, get rid of the system schemas, and would then in that schema apply somehow the user and password which you have predefined for that, probably limited to the restore host, which can be done in MySQL. And you could then check whether that's a legal user. Can it connect? If not, then obviously that schema is not prepared for selective export, and you would skip it. Fail safe, don't do anything on it. And then you would search your directory where the scripts are located for the check script or anonymization or export script, which could be a shell script or an SQL list of SQL commands, and you would apply that. You can automate all that. Set it up once, and then it doesn't matter whether your developers give you a shell script or an list of SQL commands. And then you could ask your database which tables there are, and could what does it here? It could truncate them, for example, if you want to protect those data, and allow just the selected T1, T2, T3 to be exported. You can dedicated apply an update statement to make personal names, etc., confidential, or to keep them. You could do a count star to check the number of rows for your sanity checks. How many rows do I have in recovery? How many do I have on production data? Doesn't match roughly. Very often you want to see the database schema. Say a new developer needs it, no problem. And there is, as I said before, no limit what you can do. If there were no questions yet, then I guess they will come now.
Any questions at this time? No? Okay, then thank you very much.